Hello and welcome to another video. In this video we're going to be working on minimum length of string after operations. And this one you're given a string and you're allowed to perform the following operation any number of times. Pick an index of a character and delete the closest character to that character that has to be the same. And in order to pick that index there have to be at least two more of that character. So essentially let's walk through this example. And let's actually make this a little bigger. So let's say this is A, B, A, C, B, C, B. So essentially we can pick any index of a character that has one to the left and the right of it. So like we can pick this, and then we're going to delete the closest A to the left and the right, which will be this one. So this, we'll delete this, delete this. Then we can also pick a B. Let's say we pick this one. Then we're going to delete the closest B to the left and the right. And C we can't pick at all because there's only two C's. So essentially our final string is just going to be AC, BC, B. And then the second example, you can't do anything because you don't have enough. So going back here, it doesn't really matter what index we pick, like in what order. And we don't really care about our, like we're not asked like how many different strings can we return or something. Like that would be more difficult. At least maybe. We're just asked like what's the shortest one we can return. And so these operations, you can almost think of them as like separate. Like you can basically say like a string is the sum of the counts of its characters. And for every character, as long as I have 3 or more, I can keep deleting 2, right? So if I had like 10 A's, right? If I had just like A, and so on, if I had 10, I can just say, okay, let me pick one of them in the middle and then delete one to the left and one to the right, and then it would go down to 8. Then I can delete 2 more, and it would go down to 6. Then 4, then 2. And then you need at least 3 to do the deletion. So once you realize that, like, you're basically just summing up the counts of the characters, and these operations, like, all you care about is counts of individual characters. You don't actually care about, like, their order or any like that. You just care about, like, how many characters do I have and how many deletions can I make. And then from there, we just need to figure out, like, okay, if I have some characters, like, what's my result going to be? So let's say I have 0 of a character. What does 0 map to? So 0, I can't do anything. I'll just have 0. If I have 1, I can't do any deletion, so I'll just be stuck at 1. 2, also. If I have 3, then I can delete 2, so I'll be at 1. If I have 4, I can delete 2, and I'll be at 2. If I have 5, I can delete 2, and then I'll be at 3, and then I'll delete again. And so you kind of get this pattern of, well, we can just check if our character is less than or equal to 2, right? So if our character count is less than or equal to 2, we just return that. So character count is less than or equal to 2, return that. And if it's greater than 2, then we basically just have to check if it's odd or even. So any odd character is going to get reduced down to 1. And any even is going to get reduced down to 2, because we can just keep deleting 2, delete 2, delete 2. We can't go down to 0, but if we have like 100, we'll keep deleting 2 until we go down to 2. And this is basically all we need to do. So essentially we need to go through the string, get the character counts, and then just do this basic logic. And then that's it. And that's the main thing, is like it doesn't really matter what you pick as like the index, because anytime you pick an index, you're essentially deleting 2 characters, and you don't really care which one. It doesn't matter, right? If I have like A, it doesn't matter like which one I pick at the start. No matter what I do, I'm gonna have 1 or 2 left, right? So if I pick this, you know, I'll delete this and this, and so on and so on. So every time I'll delete 2, delete 2, delete 2, delete 2, and now I can't do anything. And it didn't really matter which one I picked. Like I'm just gonna have this at the end no matter what. So I think it's closer to an easy problem, to be honest. Not super difficult. So yeah, let's code that one. So we just need character counts. So like before in Go, I'll just use an array. And then we can have 26 there. And so in Go, if you do like a range for loop like in Python, you'll get runes, and I want to get bytes because they're all bytes, so we can just do that. So to get bytes, you just do a normal for loop, and bytes are basically like characters, and rune is bigger. So yes. Alternatively, I guess I can convert the rune to a byte, and that would be the same thing. But yeah. So essentially, we're just going to say counts of s at I, which is the character, the byte. I mean, same thing. Like in Java, byte or C++ is like one, or in character is 1 byte, and in this, a byte is a character. So yeah. Okay, so essentially we want to normalize this like I did in my other problem. So you want to make A be index 0, B be index 1, and so on. So you can just subtract whatever value you want to be at index 0. So essentially this will make it like this. That way if I have like C minus A, this will give me 2, and that's what I want, right? Because ASCII, like if I don't do this, S of I is not 0. It'll be like the ASCII value for A, which is like 50, 60, whatever. So we'll just normalize, increment. And now essentially we have an array of counts where index 0 is A's, index 1 is B's, and whatever. And so now we have to go through all those counts. So we'll make a result, go through all the counts. Now we can use a range loop. So if the value is less than or equal to 2, that value is not going to change. So we'll just say result plus equals value. Otherwise, if the value is even, we will append 2. And then if the value is odd, we will append 1. And then we're done. So yeah, it's a pretty simple one. Just recognize like it doesn't really matter what I pick as the middle. I don't really care about what order I delete things. I don't have to do this one operation at a time. This will work doing one operation at a time. Like if I say like I have 15 A's, get rid of 2, get rid of 2, that will actually be fast enough because that will basically give you a linear time solution. Because essentially you're just deleting 2 characters at a time, and you can only have this many. So that will work, but this will just be faster. Big O will be the same. So. Yeah, so time is going to be ov(n) and space for all of these things where you store just an array of character counts because it's only A through Z. This is 26, so this is ov(1). So yeah, it's going to be all for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.